in the next few slides, we're going to do a little bit of thinking about the strength of acids and bases. So we were discussing how an acid donates hydrogen ions, a base accepts hydrogen ions. But that doesn't mean that you have to do it really well. Some acids have a strong tendency to donate hydrogen ions. Some of them do not have such a strong tendency. Some bases have a strong tendency to accept hydrogen ions. Some bases are not that good at accepting hydrogen ions, and they won't do it so well. So we talk about strong acids and strong bases, and weak acids and weak bases, and we deal with them differently because the chemistry they produce in solution is different. So what do we call a strong acid? A strong acid is one that is completely ionized in solution. And I've got here a few examples: hydrochloric acid, fluorhydric acid, nitric acid, desulfhydric acid. What does it mean that it's completely ionized? It means that if you dissolve it in water, so imagine you have hydrochloric acid and you put it in water, you do not have hydrochloric acid any longer when you dissolve it in water. It has completely ionized, it has completely broken down into H3O plus and the anion, the chloride anion. So the compound HCl, the hydrogen and the chlorine attach with a covalent bond to each other. When it dissolves in water, does not exist anymore. There are no HCl covalent compound, there are hydrogen ions and there are chloride anions. In the case of a strong base, it's the same. When you have, for example, sodium hydroxide, which in this case, for example, sodium hydroxide is a solid, and you dissolve it in water, in the moment it's dissolved in water, you do not have any more NaOH compound, sodium, the sodium ion and the OH hydroxide anion attached together. In this case, it's an ionic bond between those two. What you have is the ion Na plus surrounded by molecules of water and the anion OH minus hydroxide surrounded by molecules of water. The implications is that whatever amount of acid, whatever number of moles you have of acids, when you dissolve it in water, you will generate that number of moles of hydrogen ions and that number of moles of the anion. When you have a base, a strong base, and you dissolve it in water, that many moles of, let's say, sodium hydroxide you have dissolved in water will generate the same number of moles of sodium ions and the hydroxyl anions. There will be no compound NaOH as a compound at all in solution. There will be no compound HCl at all in the solution. There will be hydrogen ions, chloride anions, or hydroxyl anions, sodium ions. We call that being completely ionized. What happens if you are working with a weak acid or a weak base? Well, when you have a weak acid, and an example of weak acid could be acetic acid or citric acid, any organic acid, lactic acid or carbonic acid, for example. An example of weak bases could be, for example, ammonia. What happens if you have, for example, the compound acetic acid and you dissolve it in water? Well, when you dissolve the compound acetic acid in water, a small amount of your acetic acid will form the acid anion, which is CH3COO minus, and a small amount will form the hydrogen ions. So of your whole, all the acetic acid you started with, a little bit will ionize and will liberate acetate anions and hydrogen ions. And some of it, or quite a lot of it, will not ionize. It will dissolve, so it will be surrounded by molecules of water, but it will be still a compound. So you will have in solution a mixture of the compound acetic acid, all these hydrogens and carbons and oxygens attached together by covalent bonds, surrounded by molecules of water. This is what I'm trying to present here as HA. And you will have generated a little bit, a few ions, positive and negatives, that come from this dissociation process. So that means that the calculations and spotting how, what's happened is not as easy in the previous case. Because if you have a certain number of moles of acetic acid and you dissolve it in water, most of that acetic acid will dissolve, but it will dissolve still as acetic acid, and only a little bit of that acetic acid will have a split into acetate anions and hydrogen ions.